Today we are reviewing 7th grade geometry. We're going to start with looking at finding missing angles. So complementary angles are two angles that have a sum of 90 degrees. Supplementary are two angles that have a sum of 180 degrees. And for remembering it, I like to think complementary and the word corner, they both start with the letter C. Corner being this, a right angle. Supplementary, I think straight line. Supplementary, straight line, and that's going to be 180 degrees. All right. Vertical angles are formed with the same two lines and are across from each other. Vertical angles are congruent, so vertical angles look like this. We had two lines that crisscross each other. Make some little arrows here. This angle and this angle, those are vertical angles. They're across from each other and they're congruent, which means they have the same amount of degrees. If you are missing an angle, you can use an equation to find the missing value of the variable. All right, so let's try some. For this one, it says find each missing angle measure. Justify each answer. Line AD is perpendicular to line BE, which means that this line and this line form a right angle. All right, so when we name angles, we have to use 3 letters to name them. So let's go ahead and do that. I'm going to start here. AXF. AXF. When you name them, the letter that is at the vertex, the center there, needs to be the middle letter listed. I could have also named it FXA. It would mean the same thing. Okay, so this is this angle. Now, it wasn't a very good one. Oh, actually, it is a good one to pick. I take that back. I was looking here and thinking, well, I don't really have any information about it. But if I look here, I do have information about it. AX, if I continue that line, goes down to D. And CXF is a line. That means this one and this one are vertical. So how many degrees? The measure of the angle is 40 degrees. Why? It's vertical to angle CXD. They told us that angle. Okay, so now I'm going to erase all of this information. And I'm going to go ahead and write in that 40 degrees just so I can keep that information. Okay, next one I'm going to do is FXE. FXE. To find that one, I know this part is 90 degrees because they told me the lines are perpendicular. So I can do 90 minus 40 to find my missing angle, which would be 50. So that means this part has got to be 50. So how many degrees? It's going to be 50 degrees. And why is it 50 degrees? Well, it's complementary to angle AXF. All right, next one I want to find is this one, BXC. Angle BXC. That one's also going to be 50 degrees because look, these two are formed with the same two lines and they're across from each other. So that one's also going to be 50 degrees. And the reason is that it's vertical to angle FXE. All right, so we have 2 more missing ones. We have angle AXB. And we have angle EXD. Both of those are going to be 90 degrees. And that's because AD, line AD, is perpendicular to, this is the symbol for perpendicular to, line BE. If they're perpendicular, they form a right angle. And I'm just going to do a little bracket here because that's the same explanation for both. All right, let's take a look at this next one. Write and solve an equation to find x. So we know these are supplementary angles. They're on the same straight line. So we're going to write this equation, x plus 15 plus 120 equals 180 degrees. It equals 180 degrees because they make up this straight line together. All right, so now I need to solve my equation. My first step is going to be combining like terms that are on the same side of the equation. So the 15 plus 120 is going to give us x plus 135 equals 180. Now to get the x by itself, I have to subtract 135 from both sides of the equation. Okay. All right, so now I'm going to subtract. If you want to use a calculator, you can. You don't have to. The numbers here are not that big. But for our geometry work today, you can use a calculator. So 180 minus 135, that's going to give me an answer of 45 degrees. When you're finding missing angle measures, make sure you label things with degrees. All right, let's take a look at number 3. Angle PQR and angle TQV are vertical angles. The measures of the two angles have a sum of 100 degrees. Write and solve an equation to find x, a measure of angle TQV. Okay, so I'm just going to sketch a quick picture here. Q is our middle one. So it says PQR, that's this one, and TQV, that's this one, together equal 100 degrees. This one is x, and since this is also vertical, this one's also going to be the x. So now we have to figure out what that equals. So x for the first plus x for the second equals 100 degrees. Well, let's see, x plus x is 2x equals 100 degrees. We divide by 2 to cancel out the times 2, and we get x equals 50 degrees. Vertical angles are equal to each other. So if this one's 50, that also has to be 50. All right, so let's go ahead and move on to looking at different shapes. So we have some polygon formulas here. Rectangle is length times width. Parallelogram is base times height. Triangle is 1/2 base times height. Trapezoid is 1/2 times height times the sum of the bases. For circles, pi area is pi times radius squared. Circumference is pi times diameter, or circumference is 2 times pi times radius. When we did this test, you guys got formula cards to use. When you get to a standardized test, you'll have a formula card to use there as well. All right, so let's practice looking at a problem that involves finding area. So here it says this figure shows two shaded regions and a non-shaded region. Angles in the figure that appear to be right angles are right angles. Okay, so the first part here says, what is the area in square inches of the triangular shaped region that is shaded in this figure? That's this right here. Okay, so we need to do our triangle formula, which is area equals 1/2 base times height. It's the same thing as base times height divided by 2. So that means I need to find this part right here. Okay, well, we'll look around in the picture. There, that's 2. Okay, so we're going to put it into our formula. 1/2 base times height. So I'm going to do 4 times 2, and then I'm going to divide by 2, because times 1/2 is like divided by 2. 4 times 2 is 8. Divided by 2 equals 4. And then I can see my labels are inches here, so it's going to be inches squared. Area is always in square units. All right, let's take a look at this next one. What is the area in square inches of the non-shaded region in this figure? Okay, so we have a couple different options here. One is to find the area of the whole big rectangle, and subtract out the shaded parts, or we can add together the non-shaded parts. So either way works. I guess we'll go ahead and just add together the non-shaded parts. I'm going to erase the writing I have so far. Okay. So I'll start with this white triangle. It's the same as the other one we just found. We know the area is 4 inches squared. So I'm going to go ahead and just record that down here. I have 4 for the triangle. I did the work on the last one. Then I have this square. That's length times width. So for this one, I'm going to do 2 times 2. That equals 4. So that little square is also 4. Okay, now I'm going to split this into a little rectangle and a big rectangle. For the little rectangle, I know this side's 3, but I have to use the information on the side to help me figure out how tall it is, how this part is. And I get that from over here. This is 2 and 4, so all together this is 6. And this part is 5, and then there's this itty bitty extra piece up here. Well, if this is 6 and this is 5, this little extra part has to be 1. Okay, and since this is 2 inches and this is 1, then this is also going to be 1. So to find the area of this rectangle, we're going to do 3 times 1. That gives us an area of 3. And then for the last part, this rectangle right here. Oh, that wasn't very neat. Okay, we'll have to do some subtraction to find our lengths here. This part, they say, is 4. This part we have to subtract. It's 8 all the way across on the bottom. But we already know this part is 2. So that means this one's going to be 6. Because 6 plus this extra 2 is going to give me my total 8. So to find the area of this one, we're going to do 4 times 6, length times width, which is 24. All right, so to find the area in square inches of all of the non-shaded region in the figure, we need to add together our areas. So I'm doing 4 plus 4 plus 3 plus 24, and that's going to give me a total of 35 square inches. All right, let's take a look at this next one. Jamal will slice a cylinder into 2 congruent pieces. Which 2-dimensional plane sections could result from the slice Jamal makes? Okay, so I'm going to draw a picture, and then you are going to pause the video and put which ones you think work. Okay, here's my picture. Okay, so which ones could result? So if I cut it this way, going down, if I cut it across, if I cut it on a diagonal, go ahead and pause the video and mark in your paper which ones you think work. Okay, let's check our answers. So if I cut it horizontally this way, the picture that we see right here would be a circle. However, if I cut it straight down this way, oh, that was not straight. Imagine it straight. And we get a, oh, that was crazy, rectangle. All right, let's take a look at some 3-dimensional geometry. Volume is the amount a solid can hold. Prisms, volume equals the area of the base times height. Pyramids equals volume equals 1/3 of the area of the base times height. Surface area is the amount of area on the surface of a solid. You find the area of each side and add it together. And when you have circles involved for a cylinder, then you use this formula. So it's going to be 2 times pi times radius. Ooh, that should be radius squared. Those are the 2 area of the bases, plus 2 times pi times radius times height. All right, so let's go ahead and try this one. I'm going to get you set up, and then you're going to pause and try on your own. What is the volume and the surface area for the storage chest? Okay, volume, we're doing length times width times height. Okay, we have length times width times height. All right, go ahead and pause the video. Try just the volume part. All right, let's check our answers. 4.5 times 2 times 2. That's length times width times height. Doesn't even really matter which one is which. And when we get our answer, we get 18. And that's going to be cubic feet. So it can be written this way, feet cubed, or it can be written out. Okay, now we need to do surface area. So you need to find the area for each one. We're not going to worry about this little extra lid, that line that's looking there. We're just going to find the area of each rectangle. We're going to do length times width. You'll start with the one in the front. All right, we've got 4.5 feet here. We've got 2 on this side. So we're going to start by just finding the area for each of the sides. Each one, there's going to be 2 that are the same. So we will have 2 times one side of the rectangle, 2 times another side of the rectangle, and 2 times the final side of the rectangle. And when you get those answers, you're going to add them together. Go ahead and pause the video and finish this problem. All right, so let's go ahead and check. So for the front and the back, I've got 4.5 times 2. And I have 2 of them because I have the front and the back that are the same. 2 times 4.5 times 2 is 18. Okay, then I've got the top and the bottom. That also happens to be 4.5 feet and 2. So 2 times 4.5 times 2, well, that's also 18. And then I have the left and right side. This part and the other side, that's going to be 2 times 2. So 2 times 2 times 2, that gives me 8. So then to find my total surface area, I need to add them all together. And when I add 18 plus 18 plus 8, I get 44 square feet. For surface area, you find the area of each side and add it all together. Okay, let's take a look at this one. Find the surface area and volume for the prism. This is a triangular prism because it has 2 triangles and it has 3 rectangles. Okay, so we'll start with surface area. So for a triangular prism, we have the 2 triangles that are the same exact size. And then we have 3 rectangles, which are usually different sizes. Not always, but often they're different sizes. All right, so we'll start with the triangle. To find the triangle, you have to look for the 2 parts that form the right angle. On this one, here's the right angle. It's the numbers 12 and 16. Remember, we do base times height divided by 2. So 12 times 16 divided by 2. And then there are 2 that are the same size. So we do times 2. That times 2 and divided by 2 cancels each other out. So if you just want to do 12 times 16 to get the area for your 2 triangles together, you can. It's going to be 192. The next thing we look for on our triangle is, or our prism, I should say, it's not a triangle. On our triangular prism is the height, which is the distance between the 2 triangles. On this one, the height is 4. Height does not have to be up and down. On a prism, the height is just the distance between the 2 bases. All right, so 4. And then the other sides are going to be the sides of the triangles. So for this rectangle right here, I've got 4 times 16. For this triangle right here, this part was 4. So I have 4 times 12. And then for the bottom, I have 4 times 20. Okay, go ahead and pause the video, finish this one up. Okay, let's check our answers. So 4 times 16, I got 64. 4 times 12 is 48. 4 times 20 is 80. And then to find the total surface area, we have to add them all together. 192 plus 64 plus 48 plus 80. And let's see what we get. 192 plus 64 plus 48 plus 80. And I get 380 384. And that's going to be centimeters squared. All right, for volume, we do the area of the base, which is 1/2 base times height. And then, so that's the area of the base. And then we times it by the height for the whole shape. All right, so I'm going to erase all my original writing on here so we can kind of just focus on the information that we had. Okay, so for the area of the base, that base and height form the right angle. Base and height. Now, a lot of times people want to think base is the bottom, but it's the two parts that form the right angle. So we have 1/2 times 12 times 16. That part is the area of the base. And then I need to multiply times the height of the whole shape, which is this part, times 4. Okay, now we can do it all in one step if you want, or you can do it one step at a time. We can also do the 1/2 at the end and divide by 2. So I'm going to do 12 times 16 times 4 divided by 2, and that gives me 384. This one just so happens to have the same volume and surface area, but our labels are different. Volume is in cubic units, surface area is in square units. All right, let's take a look at this next one. So we have the surface area and volume for a pyramid here. All right, so height is 4 centimeters. We'll start with our surface area. Okay, so we need to find the different shapes. We have a square on the bottom. That's 4.3 and 4.3. I did not do a good job of writing my decimal like a decimal. It looked like a times there. Try it again. 4.3 times 4.3. All right, and then the triangle, I have 4 of them. And if I look at just one, I can see the base and height of this triangle is 6 and 4.3. So I'm going to do 6 times 4.3 divided by 2, base times height divided by 2. And then I can times by 4 because I have 4 of them. Go ahead and pause the video and finish this problem. Okay, let's check our answers. 4.3 times 4.3, that gives me 18.49. When I multiply our other ones, let's see, 6 times 4.3 divided by 2. And that gives me the area of 1 times 4 because we have 4 of them. It's going to be 51.6. And then my last step is to add our two answers together, 18 and 49/100 plus 51 and 6/10. And that's going to give me 70 and 9/100. And that's going to be centimeters squared. Surface area is always in square units. All right, volume. For a pyramid, we do the area of the base, which on this one would be length times width, times height, and then we divide by 3. Go ahead and pause the video, try this one. All right, let's check our answers. Length times width, 4.3, 4.3. This time we want actual height, not slant height. That's up here, 4. And then we're going to divide by 3. So let's see, 4.3 times 4.3 times 4 divided by 3. So we get 24.653. It did not say to round to the nearest tenth, so I'm not going to round. That's going to be centimeters cubed. All right, let's find the surface area of our cylinder. So here's our formula, 2 times pi times radius squared, that's the area of the two circles. plus 2 times pi times radius times height. That is the lateral surface area. That's the rectangle that wraps around the middle. 4 is my radius. It's the distance from the center of the circle to the outside. 12 is my height. All right, so we're going to go ahead and use 3.14 for pi, and we're going to put in our numbers. 2 times 3.14 times my radius, 4 squared, which means I'm going to do it twice. 2 times 3.14 times 4 times 4. Okay, so let's see. 2 times 3.14 times 4 times 4 gives me 148 hundredths. That's the two circles together. Now I'm going to do the second part. 2 times pi times radius, but this time instead of doing radius twice, I'm doing the height. All right, so I have 2 times 3.14 times 4 times 12, 301, 44 hundredths. Okay, and to find my final answer, I'm going to add those two things together. And it looks like my surface area is going to be 401 and 92 hundredths, and that is going to be feet squared. Okay, let's take a look at angle measures. Which set of measurements can be the interior angle measures of a triangle? Interior angle measures of a triangle have to equal 180 degrees. So you're going to check to see which ones equal a total of 180 degrees. Go ahead and pause the video and try this one on your own. Okay, let's check our answer. So we got to start by adding 10 plus 10 plus 160. Okay, that's going to be 180. Let's see, 15 plus 75 plus 90. That's going to be 180. Let's see, 20 plus 80 plus 100 is going to be 200. Okay, let's see, 35 plus 35 plus 105 gives me 175. And then 60 plus 60 plus 60 equals 180. So the ones that work are A and B and E. Okay, let's take a look at this next one. Which sets of measurements could be the side lengths of a triangle? Select each correct answer. So to check on these, we have to add the shorter two. So the sum of two short has to be greater than the longest side. Okay, so let's go ahead and check. So for the first one, my shorter two, 3 and 3, and seeing if it's greater than 3. 3 plus 3 is 6. Is greater than 3. Yes, that one works. Go ahead and pause the video, check the rest. All right, let's see. 4 plus 8 is 12. 12 is less than 13. So nope, that doesn't work. 5 plus 9 equals 14. That equals 14, so that doesn't work. 6 plus 7 equals 13. 13 is greater than 8. Yep, that one works. 7 plus 7 is 14. 14 is greater than 10. So yes, that one works. So A, D, and E. Okay, and our last two, find the circumference and area of each circle. Use 3.14 for pi, round to the nearest tenth. Remember, our formula for area is pi times radius squared, and our formula for circumference is 2 times pi times radius, or you can do circumference equals pi times diameter. You do need to be careful to see which one you have. On number 12 here, we have a line all the way across. That is our diameter. On number 13, we have the radius, which is 3. All right, let's go ahead and do 12 together, and then you'll try number 13 on your own. Okay, so for 12, we'll do area first. In order to get the area formula, we need the radius. So we have to do 8 divided by 2 because the radius is only halfway across, is 4. That tells me from this center part out to the edge, this part is going to be 4. Okay, so area equals pi. We're going to use 3.14 times radius squared. So pi times 4 times 4. And let's see what we get when we do that. 50 and 24 hundredths. And that is going to be inches squared. All right, and then let's see circumference. I know my diameter is 8, so I'm going to use this one. 3.14 times my diameter. And when I do 3.14 times 8, I get 25.12 inches. Okay, go ahead and pause the video. Try number 13 on your own. All right, let's check our answers. So for this one, area equals, my radius is 3, so I do 3.14 times radius squared, which means I multiply it twice. So when I do that, I get 28.26. That's going to be inches squared. And then for my circumference, I'm going to use the second formula here because I have a radius. 2 times 3.14 times my radius of 3. So when I multiply 2 times 3.14 times 3, I get 18 and 84 hundredths inches.